Look at this logistical sorting facility. It moves thousands of packages a minute with mechanical precision until one conveyor belt jams. Instantly, the entire multi-million-dollar system paralyzes. Most organizations treat planning as a linear timeline. You list the tasks, assign the deadlines, and push forward step by step. It assumes a friction-free reality where every phase triggers the next. But when reality introduces friction, a rigid timeline shatters. The Japanese industrial and artistic tradition operates through dandori. While commonly translated as preparation, its true application is systemic architecture. It is the cognitive ability to dictate an operational reality by starting at the end state and reverse engineering the environment required to achieve it. There is a dividing line in professional capability. On one side is the operator who executes a set of instructions. On the other side is the architect who possesses the spatial and temporal awareness to write those instructions. Elite planning abandons the fragile paper checklist. It relies on imposing extreme constraints, calculating systemic slack, and building high-yield systems that actively absorb chaos. To understand how this architecture is built, we have to scale down to individual cognition. The architect Tadao Ando relies on a specific cognitive exercise he calls image training. Before drafting a single line, Ando walks the raw construction site, sometimes 15 hours a day. He forces his brain to visualize the completed structure in its final physical context, then mentally runs the entire construction process backward. He deduces the sequence of concrete pours, the necessary material limits, and the exact staging required to arrive at that specific geometry. This relentless reverse engineering is what allowed him to conceive projects like the Church of the Light. The manipulation of heavy concrete to capture an exact, ethereal sliver of sunlight requires a sequence of actions that can only be planned if the final image is uncompromisingly fixed in the mind. This strict adherence to a terminal vision applies to sustained, granular execution as well. We see a perfect illustration of this in Stephen King's The Shawshank Redemption. Andy Dufresne is trapped in a hostile, highly controlled environment. Yet he spends decades executing minute, repetitive tasks, writing hundreds of weekly letters for a library budget, carving a few ounces of concrete from his cell wall every night. These localized actions were sustainable because he anchored them to a fixed macroscopic vision, a hotel on a specific beach in Mexico. Action without a fixed end state consumes cognitive energy without yielding systemic change. Progress requires compounding microscopic inputs against an unyielding macroscopic vision. That macroscopic vision often requires friction to take shape. We see these mechanics on the manufacturing floor of Toyota. Most corporate efficiency drives mandate a standard 10 to 20% reduction in costs. When you ask a system to improve by 10%, the operators look for superficial inefficiencies. They trim a little waste, optimize a few supply lines, and maintain the existing core architecture. This chart compares a standard incremental goal against an extreme constraint. Following a 10% trajectory extends the life of the current system. But Toyota is known for mandating a massive 50% cost reduction target. A 50% reduction is mathematically impossible to achieve through minor tweaks. It forces the engineering team to abandon their baseline assumptions entirely and rebuild the operational framework from scratch. The impossible constraint becomes a generative tool. This deliberate imposition of friction scales to elite physical performance. Olympic gold medalist speed skater Hiroyasu Shimizu applied this logic to his own physiology. Shimizu understood that muscles are highly adaptive and easily habituated. If he repeated this same optimal training loop, his neurological response would plateau, altering his mechanics, changing his coaches, and forcing new physical stressors. He broke his own optimal routines to force continuous neurological adaptation. Setting a reasonable target yields minor adjustments. Imposing an extreme constraint strips away existing safety nets and forces an operator to architect an entirely new methodology. When these newly architected systems scale up to macroscopic infrastructure, they encounter a new problem: density. Look at the JR East rail network in Japan. Millions of passengers move through these stations daily, with the headways between incoming trains compressed to a staggering, unforgiving 2 minutes. Punctuality here is achieved by deliberately embedding the absorption of entropy into the system's design, rather than assuming flawless human execution. This graphic shows the master timetable schedule grid for the rail network. The planners achieve resilience by scheduling what they call the invisible train. They embed theoretical, non-active train paths directly into the timetable's math. When an inevitable delay occurs, say a platform issue or a minor mechanical fault, that disruption begins to ripple outward. Instead of colliding with the next scheduled sequence, these ghosted routes activate as a mathematical buffer. The system recalculates the flow, routing the disruption into the empty space without causing the grid to collapse. We see the same calculated use of empty space in creative workflows. In the 1970s, the magazine Popeye revolutionized editorial production. When their editorial teams traveled overseas for reporting, they explicitly scheduled blank space and unstructured hours. This intentional slack allowed the journalists to follow serendipitous leads, pivot to unexpected stories, and capture the raw cultural energy that rigid scheduling would have suffocated. A schedule maximized to 100% capacity is brittle. It possesses no kinetic energy to absorb a shock or seize a sudden opportunity. True optimization requires the deliberate engineering of voids. Even with slack, environments can experience total structural failure. In 1970, the Apollo 13 spacecraft suffered a catastrophic oxygen tank explosion, violently venting vital gases into the dark vacuum of space. The entire mission manual was instantly rendered obsolete. In Houston, flight controllers were drowning in failing telemetry data, forced to abandon their granular mission steps because the environment was degrading faster than they could calculate. To regain control, they stripped the mission down to a scarecrow schedule. This is a highly abstracted sequence. It ignores precision and prioritizes massive macro dependencies, securing the critical path for survival before attempting to resolve the minutiae. Once the structure held, only then did they populate the blocks with precise data, like power distribution limits and oxygen consumption rates. But a schedule is only as robust as its execution. In high-stress environments, human cognition degrades. To combat this, Japanese railway operators utilize point and call, a mandatory physical gesture paired with a vocalized confirmation of status. The exhausted Apollo 13 astronauts relied on the same psychological mechanism. Operating on near-zero sleep, they bypassed cognitive fatigue by physically pointing to switches and reading the commands aloud for Houston to garify, preventing a catastrophic input error during their final engine burn. When standard operating procedures disintegrate, survival depends on rapid abstraction. Deploy a macro-structural baseline like the Scarecrow schedule to stabilize the timeline and anchor it with rigorous physical micro-verification. We see this duality of the micro and the macro in the career of hotelier Tetsuo Kuboyama. He began his hospitality career scrubbing toilets, painstakingly learning the precise physical mechanics of removing stains. Decades later, he was architecting corporate pension systems and re-engineering ventilation airflow across entire hotel properties. Mastering these extreme micro-manuals provides the necessary resolution to eventually observe a system's metastructure. You cannot optimize the airflow of a commercial kitchen if you do not intuitively understand the physical heat generated by the line cooks. Physical execution and abstract intellectual planning share the same DNA. Whether mapping the operational timeline of a luxury hotel or using a strict 3-part framework to outline a complex essay, the underlying geometry is identical. You isolate the variables, establish the sequence, and construct a pathway connecting raw materials to the terminal state. That is the essence of Dandori. Reverse engineer the outcome before taking a single step. Embrace extreme constraints to force generative new designs. Deliberately embed slack into your timelines to absorb friction. And when systems fail, abstract the timeline into a baseline structure protected by relentless micro-verification. Professional planning reaches peak when an architect perceives the hidden mechanics of a task so clearly that they transcend simple execution to become the author of the system itself.